Hi guys, this is Jason Horner, presenting on Dimensional Modeling Design Patterns, and with me I have Carlos Bassi, Reeve Smith, and Josh Fennessy. Really happy to have them on board. They're going to help me kind of go through this slide session with you guys tonight. The reason I have them here, aside from the fact that they're all really smart, in fact probably much smarter than me, is just for the fact that this session works better interactively, so I'll kind of be handing things over to them to ask different questions as we go through the session. And by any means, if you guys have questions or whatever, definitely you can tweet at any of us or past virtual VC tweet, ask specific questions, and hopefully towards the end we'll have some time for some Q&A. So let's get started.
Just before you start, Jason, I just want to make sure that you're aware that the screen is actually showing the presenter view instead of the full...
Oh no. Why is it doing that?
And now you've all seen the magic behind the curtain.
Yes. That's our cheating tool.
Hang on a second. Let me see if I can...
So while Jason's doing that, yeah, I'll be monitoring Twitter as well. So in case if you want to ask any question, don't forget to tweet to @PassBIFeezy. And yeah, and then I'll raise all the questions or comments to Jason if you prefer to use Twitter. But if you prefer to use GoToWebinar, just type in questions and I'll monitor that too.
All right, let's see. Is that better, or is it still?
It's still showing the presenter view.
Let me see here. That's weird. I switched it. Hang on a second. Let me see something. All right, let's try this one more time here. Okay, is it going now?
Nope. We can see your desktop.
All right, let me try moving it over one more time.
If not, it shouldn't be too much of a problem.
Yeah, just
Well, it keeps wanting to use the. You gotta
change that monitor there.
To the, yeah, let me do this.
Under the slideshow menu, Jason, there's a Use Presenter View.
Yeah, I turned that off.
Unclick that. Okay.
Yeah, so I'm not sure. I'm gonna just change my desktop real quick.
Okay.
Sorry about that. Oop.
Or do you need to have it Use Presenter View?
No. Okay. Is that better?
Yes, that's good.
Okay. Sorry about that. All right. So today we're going to go through a very simple sales scenario. Company called Initech. They sell widgets. What's a widget? Nobody knows. All BI companies seem to sell them, so that's what we're talking about. They basically deal with sales order management. They've got users that are frustrated because they're hitting the online transactional processing system. They're not able to get the kind of reports they want out of there. So one of the things I like to do, because before we really get into it, is I like to figure out, well, why do we really need dimensional modeling? Like, why can't we just hit the source system directly? And what are some of the problems with that? So, Carlos, in your experience, can you tell the folks some of the reasons why we wouldn't want to just go off of a operational online transaction processing system?
Yeah, a lot of it has to do with how we set up online transactional systems, and we do it so that they can store transactions really fast and easily for applications, but they don't do well for reporting. The data model that we have in OLTP systems doesn't support reporting very well. So when we turn the data into a star schema, it makes it actually much easier to report on and much more straightforward, where a good user, a power user, can quickly and easily write reports.
Yeah, and then sometimes some of the other things that I've seen kind of come up is obviously you need to consolidate data from several sources, right? So maybe you have multiple customer relationship management systems, maybe you have multiple enterprise resource planning systems. Also, you can't capture history in an OLTP system, or most systems aren't built with that historical aspect. So the data warehouse is really your first place to capture that. And Carlos really spoke to the OLTP versus OLAP style workloads. And then also, reducing the load on the operational system. So one of the main things we do oftentimes is we'll forklift the data right out of the source systems into our staging area so that the ETL load and a lot of the query patterns aren't hitting that system directly, but they're hitting a copy. And ideally, if you have a properly designed data warehouse, the copy will be in the dimensional model format, which, again, reduces unnecessary joins, stores data really efficiently. So those are some of the reasons. Reeves or Josh, any other reasons why we might use an OLTP system or a dimensional model system as opposed to the OLTP system directly?
One thing I can add to that, this is Reeves, one thing I can add to that is grouping sometimes are not in your online systems. Your OLTP systems, you wouldn't have groupings, you'd have age, and sometimes those ages don't make as much, or they don't make the reports that nice to look at from a standpoint until you put those into buckets, and sometimes that your OLTP systems don't have that, and that's things that don't exist in the system that you want to put into your dimensional model to make reporting a little bit better.
Yeah, that's a really good point, Reeves. I mean, oftentimes I've worked with SAP systems where we've got all these operational source codes too, and sometimes the end users are in kind of in a culture and an environment where they they want to see those operational codes, but oftentimes they want something a little bit more cleaner, or they want to do some grouping, and sometimes you have more than one operational code that ends up in a bucket, right? So it's a really good point that from the DW perspective, you can add that kind of analysis capability to enrich your dimensional model. Josh, anything to add to that?
Yeah, I mean, I think another good point of using dimensional models, or if you ever want to go down the route of using an OLAP style engine like Analysis Services, those kind of databases are best built from a dimensional model. They're kind of catered to that design pattern. So, having that data warehouse or that data mart pre-built kind of really expedites the development of an OLAP style system.
Yep, I definitely agree with that. And it's actually, even with the tabular model that they're coming out with today, since you're basically just bringing those tables in relationally, it matches really good to have a dimensional model. Now, you don't need one. You can do the joins in Power Pivot or BIDS, wherever you're designing your model in, but to have that pre-structured definitely helps out a lot. So it's good points, guys. So moving right along, this is what often happens. I mean, they usually have a web developer or some such that took a class maybe on dimensional modeling or read something about it, and he's going to take the first stab at the model. And so what you typically end up with is something that looks like this. Now, it's a lot better than probably the OLTP system, but there's probably still some issues with the design of this system. Josh, do you want to start us off and point out some of the issues here?
Sure. I'm assuming we're looking at a database diagram.
Yep.
All right, I'm not seeing the update on my screen yet, but I mean, I think so. One of the highlights of a dimensional model is that we've denormalized a lot of the data, right? So we've gotten rid of a lot of those joins that we might need to make in our OLTP system. So, I mean, right off the bat, one of the things I see is we have a table called sales fact that joins directly to sales order dimension via one field. In a dimensional model, we want to really try to eliminate as many of what we call snowflakes as possible, which means, if we're just going to join to a table and it's a one-to-one relationship on one field, I think we can probably combine those into a single table as opposed to having those be two tables.
Okay. Yeah, I mean, the real key here is that if you think about so we talked about star versus snowflake. So when you have typically
Hey, Jason, real quick.
Yes, sir.
I'm sorry. We're not seeing the database diagram.
Uh-oh. That's not good.
I don't mean to interrupt, but...
No, that's fine. But you guys see the slide with Milton in it when I move back?
Mine just says sales scenario.
Yeah, mine also says sales scenario as well.
Let me try to pause it and restart it. Reeves and Carlos, are you having the same problem?
Yeah,
yeah,
colors
yeah.
as well. Yeah.
We see sales scenario on the screen.
Okay. Let's see what happened here. Show my screen name monitor. All right. What do you guys see now?
Now we see why do we need in your editing mode.
Okay. So, all right. So if I go to, why is it moving? It seems like my monitor's having a heck of a time with this. Let's see here. Let's bring that up. Yeah, it keeps trying to put it over on the other screen. I've extended it. Hang on a sec. Okay, guys, can you see the dimensional model now?
Yes.
We can.
All right, sorry about that. I don't know what happened. It looks like it reverted on me. So, yeah, what we're talking about is, when you have a snowflake schema, you have multiple joins coming off of the fact table, and it looks more like a third normal form. The star schema typically has a central fact table or maybe a cluster of fact tables with single table joins across through the cluster. And one of the key things is that you're going to want to use conform dimensions, which are dimensions that are defined to be at a certain grain, like customer dimension, which would be at the grain of a customer ID. Now, when you do that, you want those to conform across some of the other sales facts so that you can reuse those customer dimensions across many fact tables. Now, what Josh was pointing out is the case of the sales order dimension. The grain of the sales order dimension is probably the same as the fact table. It's one row per order line ID. And what happens is you have a large one-to-one join in memory, and oftentimes that can bog down the SQL query optimizer if there's not enough memory. So what Josh is kind of leading us to a design decision to fix here is to move the order number, line number into the sales fact table, store that operational key, and use a degenerate dimension pattern, which is basically when we have a transactional identifier that we store in the sales fact table. That allows us to perhaps repurpose the sales order dimension at a different grain, probably a higher grain, with less rows. Carlos, do you want to walk us through another potential issue with the model?
Yeah, I think, I see product category, product subcategory, and so, collapsing those two together seems to make sense. It simplifies the model, and in dimensional modeling, we're not too worried about duplicating data in some cases. So we might have product category, the same product category in multiple rows, but it's a limited amount of data. And then what I would probably do, since we're getting rid of the sales order or the sales order data off the sales order dimension, is bring that product data all together. So maybe just have a product dimension where the product category and subcategory are in the same dimension as the product data as well.
Okay, cool. And Reeves, do you see anything that you might try to change here or do differently?
One of the things I do in the customer dimension, it seems to me like you have country, state, so like a geography. I'd probably pull that out from the customer dimension and use that so that you could use that for other geographies besides the customer dimension and fill it completely if you didn't have all the data coming for your customer.
Yep, so that's a good pattern, and we'll look at that one probably in depth a little bit further down the road. So a couple other things that you'll notice here is there's no date dimension. So typically in a data warehouse, every dimensional model is going to have one or more date dimensions, and you typically create a single table. I like to use calendar instead of date, and the reason for that is calendar isn't a reserved word in SQL, whereas date is. But that's kind of an aside, and it's a personal preferencing. But I create this table, I pre-populate it with the range of history I need to support not only the the data in this fact table, but in any of my other fact tables. So a good rule of thumb is probably 40 years, maybe 30 years of date values. And then I enrich that table. I add not only the actual date value, which becomes really key when you bring it into a Power Pivot model. Power Pivot needs an actual date field type to use as when it creates the time intelligence. But I would also then create a bunch of, so I've got quarters, I've got months, I've got, what day of year is it? Is it a holiday? Is it not? I'd create all that in a single table, and then I would link it back to the fact table 3 times for my due date, my order date, my ship date. The other thing I'd like to point out is that these tables, while they have natural keys, which is just the business identifier, there isn't any unique constraint put on those, and so I would consider adding that. Now, there's a little bit of a rub there if you need to track history over time or bring, for example, multiple customers from different customer relationship management software into the same table. Customer ID can no longer be unique, so you need maybe to add a source system identifier to that key, to that natural key, or maybe a begin and end effective date. And we'll look very briefly at the different types of slowly changing dimensions patterns that you can use to handle that, to track history over time. So with that in mind, let's continue down the road. So again, we hit on star versus snowflake. We talked a little bit about the grain. So the grain is basically just what level of detail are we storing the data at. So both dimension tables and fact tables will have, you want to define a grain, declare a grain. And so that's, I'm storing in the customer table, I'm storing 1 record for every customer ID with all the related attributes. Then another concept that we didn't touch on is additivity. In the case of the fact table we just looked at, it's a transactional fact table. And so it's fully additive across all those dimensions. But you can get into other situations where it could be semi-additive. So maybe it's additive across all dimensions except for 1. Or it could be completely non-additive. And usually that would be the case for ratios if we were storing them in some kind of an aggregate table, a little bit more advanced. So we talked about primary keys. In general, we have.
Hey Jason, I'm sorry. If you're changing your slides, we're still not seeing slide updates.
Oh my gosh, are you serious?
Yeah, I'm sorry.
That's all right. When did you guys stop seeing them from the model?
We're still just seeing the dimensional model.
I'm not sure what's going on here. Let me pause that. Let's try that. All right. What are you guys seeing right now? The basics?
We're seeing the diagram.
Are we still seeing the diagram?
The stars.
Yeah, that's so weird. I don't know. Let me try this. All right, now what are you guys seeing?
It's still the GoToWebinar screen.
Okay.
What we might do, if I can make a suggestion, Jason, to just show the PowerPoint without using the presenter view. That way we can just move on, because we still can't see it anyway, if it's all right with you.
Okay, yeah, that's fine, and it should work. Okay, so can everybody see what we have right now? We should be back to the. Let's see. We should be back to the dimensional model, yeah.
Not yet. So we can't see your screen yet.
All right. Now you can see it?
Not yet.
Uh-oh. I don't know what's going on. This is so bizarre.
Okay. What I might do is let me just open up your slide deck and see if I could actually control it from my end.
Okay. Yeah. Sorry about that. I don't know.
No, that's okay.
What's going on.
That's all right.
Maybe if I put it back in presenter view.
Okay, I'm just going to change the presenter to me. Let me know where you're up to.
We should be on slide 8.
Okay, just a second. Can you guys see? Hang on, sorry, let me just... just a second, guys. Sorry about that. Okay, can you see the keys now? Is that what you're after, Jason?
Yeah, it's still not refreshing for me, but it looks like it's trying to.
Yeah, there it goes.
So we've got basics, which you talked about earlier, and then now we're up to keys. Is that right?
Okay.
Yeah.
Yeah,
Okay. Just
so
cue
go back
next
to-
slide if you want me to change to the next slide. Okay. Thanks.
Okay, cool. All right. Hopefully it'll work now. So we've got primary keys, and then inside of primary keys, you really have a couple different concepts. We talked about the natural key or alternate key, and that's really the business identifier. And sometimes that's an integer, sometimes it's a character string. Then you also have in the data warehouse surrogate keys. Now those are typically sequential integer values, with the exception of the date table. Oftentimes in the date table you use what's called a smart key, and I typically use format year, month, date. And basically that gives you a nice integer key that kind of encodes the date value, because we know that the dates are never going to change. You're never going to have to update, restate those keys. And then you also have foreign keys. Now, foreign keys in the dimensional model are kind of contentious. Some people don't believe in them, but I think they're important to enforce those, because oftentimes you have ETL processes that can corrupt relationships in the fact table when they do updates. And I also like to put a primary key, the surrogate key, on the fact table itself. Guys on the panel, do you have any thoughts about putting surrogate primary keys on the fact table versus, and also foreign keys, or opinions?
Well, I typically
Yeah, I mean,
do put them
go
on
ahead,
fact
Carlos,
tables, but a lot of that is just because it's maybe a habit, and you want to make sure you can you load the data in a certain way and it's structured in a certain way. I'm kind of ambivalent about it though myself.
Okay, Josh.
Yeah, I think I'm a fan of using foreign keys, primarily for a couple of reasons. One of the reasons you had mentioned, Jason, about loading ETL and having that enforcement kind of makes sure that the process that I'm running is correct. And another reason too is in my role, probably like something like 80 to 90% of the data marts or dimensional models I'm building are going to be used against an OLAP data source, or going to be used for an OLAP data source. And making sure that those foreign key relationships are valid is incredibly important for OLAP processing. So I tend to like to use those foreign keys to help enforce that, because if I'm going to have some sort of failure, I'd rather have that happen at the ETL phase than invalidate my analysis services database by having a bad relationship there. As far as surrogate keys in the fact table, it's kind of like Carlos. Like I use them just kind of out of habit, and I think it's more or less to make sure that that table is not a heap in SQL Server. But I don't do a lot of analysis to determine if that's really the right course of action every single time. I'm sure there's probably cases where it's not the right course of action, and you probably may want to heap there. But I do use them almost exclusively out of habit.
Cool. Reese, anything else to add?
I was just going to add, I use them generally on smaller fact tables. As the fact table gets larger and I start running in performance or space issues, those are times that I'll take them off from the standpoint, because that's a space consideration that I don't have to necessarily have from the standpoint of the primary key on a fact table.
Okay, cool. Yeah, good stuff. Josh, I really liked your point about the analysis services, because I've had to come in and debug cubes when they've had the unknown processing errors set, and you have two unknown rows sometimes, or data just doesn't show up in the cube, and it just makes it really frustrating to deal with. So that's definitely a good point, especially if people are going down the analysis services route. So Next slide, Julie.
Okay, before we move on, we do actually have a question.
Okay, great.
Okay, so this one is from Janice, and she said, should I use a ledger-style fact table to keep track of values as their status changes? For example, a document value should be in a pending column while the document itself is pending, but should then be in a committed column when the document is finalized.
Yeah, so we'll talk about that pattern a little bit. What I typically use for that is like an or a status history table, where as the document status changes, I'll create a fact table that has the begin and the effective date time of the status it was in, and then add new rows as the status changes. But I'll also probably will show an example of the accumulating snapshot, and as long as you have a nice linear process, you can use that to track it. And depending on what types of reports you're trying to do off of them, one or the other table pattern might be more appropriate. And I think that's a really good thing to point out, is that oftentimes you may have multiple fact tables for the same information. Obviously it gets expensive when you start talking about high volumes of data, but there's other ways to handle that as well. But sometimes to do analysis for a business process, you need one or two fact tables to support that provides a different vignette on the business process. So that's a good question. We'll definitely in a few slides here look at that a little bit further. But in general, you want to use kind of what I call the status history pattern. So can we go to the next the date time slide?
Yes, it should be date time slide now.
Okay.
Is it showing?
Cool.
Yeah.
Yeah, I think my thing is I'm not seeing anything, so I'm just going to be kind of going through this kind of blind. So
Okay.
Handling date time. So the biggest thing first is you got to go back to your requirements, and you've got to say, okay, do I need to deal with the analysis of just the date, or do I need the date and the time? So like I said before, you'll create a calendar table if you need just the dates, or you might create a clock table that stores your times. And typically the grain that I use for that clock table is 1 row per minute, which gives you about 1,440 rows. For the calendar table, obviously you store it at the daily level, 365 of those per year, and then however many years you need. Again, the key choice is going to be a surrogate smart key 9 times out of 10. Now, I don't necessarily always recommend a surrogate smart key for the clock, but that just kind of depends on. And then you could also use potentially, though I don't see this getting a lot of traction, is the SQL Server data type. And the reason for that is that it's kind of harder to represent concepts like unknown, not applicable, hasn't happened yet, and things like that. Now, you can always use out-of-band dates, you know, like so dates that are way earlier than when your calendar should logically start, but that isn't always as clean as just being able to put an integer value like a -1 or something there. Guys, maybe Josh, do you have any insight on kind of some trade-offs or things that come into play when designing a calendar or a time dimension table?
No, I mean I think you're right on the money. You know, I absolutely like to use the smart key for dates. It's a really quick calculation to calculate that smart key for any date. It works great, and it doesn't use a lot of disk space to store those. The one thing I will say with using the data type, again, you know, my standpoint is a lot from analysis services because I'm building these to support that. But for some of the time intelligence for analysis services, you do need to have your date key as a data type. That doesn't mean you have to have it as the key in the warehouse, but in the analysis services you do. So just kind of keep that in mind that you know, we absolutely want to have that data type field in the table. It doesn't have to be the key, but it should be in the table because we're probably going to need to use that. But again, you know, like Jason said, I think the integer key is the way to go, especially when you're looking at handling things like unknown dates or out of process dates. So I think that's right the way to go.
Reeves, anything else on the time dimension stuff?
No, just kind of the same kind of things Josh was talking about. One of the things that I've started trying to do, just as a trick, is to throw the date dimension into the value for the key. So if you're using the key and you always have the key, you can easily get to the value, and that being a date time or a data.
Yep. Okay. Cool. Yeah. So next slide. So now we're looking at the slowly changing dimension approaches, And the joke I usually tell about that is I ask the audience, well, how many slowly changing dimension approaches? And usually somebody will say, well, there's 3, right? And I say, well, no, actually there's now 8, depending on how you start. And I asked them, well, why is this? Why did this change? And I said, well, because Kimball needed to sell more books, right? Because the 3rd edition now talks about these other dimensional, slowly changing dimension approaches. But basically, what you're doing here is you have attributes like maybe a product dimension or a customer dimension, and some of those attributes are going to change over time, right? And so you need to take a look at your business requirements to say, well, what are my requirements to handle this change? If the customers aren't interested in that change, you could probably go with a type 1. That's going to be your simplest ETL approach. The downside of that is you're going to lose history, right? A type 0, I've never seen this in the wild, but it's just basically no updates ever. Some of the big data people are talking about, let's say you get a CSV feed from some data source, just throw that into Hadoop, and then when you get an overwrite, don't update the data, just throw the next version of the CSV in there and let Hadoop sort it all out. I'm not sure if that's a great approach or not, but it does support a lot of flexibility because you have all the information ever generated about that object, whatever you're tracking. Another approach I see very infrequently is the type 3 or the hybrid approach, which basically you're storing the current value as well as the previous historical version. And then all of the other types, like your type 4, type 5, type 6, type 7, those are all types that you use in kind of more advanced situations. And it's usually what you're doing is you're isolating a subset of attributes that change very rapidly into its own kind of mini dimension. And then you're adding type 1 or type 2 behavior on that. So you can always see, for example, what was my current customer age demographic, for example, and then what was it as of the time the transaction was recorded. So that's really supporting those kind of more advanced use cases. So let's go to the next slide. And we should be seeing common suffixes. So one of the things you'll notice about the model is that it was very consistent, and it's very important to remember. Much like when you're writing C# code or VB or whatever, you want everything to be consistent because the code's going to be read multiple times, but only written once, right? So you want to use consistent suffixes. Some people even like to do like dim date, or I like to use date dimension. So I actually like to use a suffix instead of a prefix. And the reason, it doesn't really matter, you just need to be consistent, right? And so when people look at my models, they can always tell, oh, it's amount, well, it must be a monetary value. Or if it's a quantity, it's going to be a count value, right? And so on and so forth. Guys, do you have any other kind of rules of thumbs? Maybe Carlos can kick us off for kind of ways that you keep your data models consistent.
I mean, one of the things we should mention is that there's also, sometimes different types of tables can be introduced here, like bridge tables and other types of data types that you haven't mentioned. So I think people should be aware that, while we talk about a lot of times dimensions and fact tables, there can be other data constructs that also have to be accounted for, and they're not really either one, dimensions or facts. And so that's one thing I would just mention to people to be aware of.
Yep, and we'll definitely look at that in the next model. Reeves, anything else to throw onto that in terms of what you're doing in your data models?
The big thing I like is to remove the dim and fact from whatever the customer would see, because the customer doesn't need to understand or doesn't necessarily have that business language. So I'm real big about cleaning up the schema that's presented to the customer and not having codes and not having dim and fact and language that we use. So I'm really big about really making that model a user interface that the business user would understand.
Yep. Okay, cool. Next slide, Julie. So, and here's the end users that Reeves was talking about, so that's a pretty good segue. They're still having problems with the model, obviously. We've talked about some of the reasons that they're having problems, but they're not very happy, right? So if we go to the next slide, what do business, well, when we go to the next slide, you'll see that the data modelers reply as, well, it's either got to be the SAN or the network, right? Because it's always an issue with that, it's never the dimensional model design. And of course, that's not really the case, right? It's a lot of times your performance is limited by the modeling choices you made or didn't make. Next slide. So, of course, what do? They send in the consultants, right? And so they start interviewing, and their job is to extract a lot of money out of the poor company. And but they come in, and if we go to the next slide, you can see the changes that they made to the dimensional model. They definitely fixed some things here that we talked about. We've now got a product dimension table that has all the attributes. We've got a unique key on product SKU. We've got a calendar dimension that we can use as a role-playing dimension, so it has 3 relationships back to the fact table. But we still didn't fix one of the issues that Reeves hit on, which was the geographic mini dimension. So probably look at that down the road. Let's see if there's anything else I want to kind of highlight there. I think that's it. The key thing to me is make sure you put unique indexes on things and foreign keys to validate that errant ETL processes can't mess up your load. So of course, now that the data model's kind of humming along, we go to the next slide, we've got new requirements. And of course, those always come from the salespeople. And they want to support sales groups analysis. They want to analyze orders by size and probably a bunch of other requirements that they'll think of. Now, of course, this request always comes in at around 3 o'clock on a Friday. And the salesperson goes to the manager, and he's like, yeah, I think we can have this done by Monday. And if we go to the next slide, we'll see that a plan is made, and the manager goes back to Milton, and poor Milton isn't happy, and he says he's going to quit, but of course he probably won't, because he needs a job, because he's got a mortgage, so on and so forth. And we go to the final slide, we'll see the new enhancements. And a couple things that we did here, we added, as Carlos was talking about the bridge tables, there's 2 types of what I call permissible snowflaking in a dimensional modeling environment. The first is a bridge pattern, and that's what we've done with the sales group analysis. We've basically, we have multiple salespeople. For example, Larry, Mo, and Curly, they're working together to sell widgets, so we want to count them as a single kind of group. And we don't really care the order that they're assigned to the team in. So we can do all sorts of things in SQL to make sure that whether it's Larry, Mo, or Curly Mo, and Larry, that always comes up as the same group. The key thing that we're trying to do here is resolve the many-to-one relationship. So putting multiple salespeople into a group. We can also add an indicator to that sales group dimension table to say, is it really a group or is it just a single salesperson? Because sometimes it might still be a single salesperson. And then if we need to allocate, say, for example, for commission purposes, we have an allocation factor attribute that can be used to assign each salesperson their own allocation. The other type of snowflaking that we've done is we have the geography dimension, and that's really an outrigger pattern. And what we've done is we've isolated a set of repeating attributes or logically related attributes into a table. In this case, it's called geography, so that the customer can have potentially multiple relationships back to that, but we can also use that geography dimension across many dimension tables. So the salesperson is probably going to have a geography, the customer has a geography. Another example where I've seen this done is, for example, with phone numbers or contact addresses. Maybe you have a bill to, maybe you have a ship to, maybe you have a sold to. Oftentimes, though, you might model that as a role-playing dimension back to your customer. It just kind of depends on the business scenario. So I guess I'll start off with you, Josh. Is there anything here else that you think we should call out about the role-playing, or sorry, the snowflaking tables?
No, I mean, I think, overall, this is a pretty standard methodology when you have some complicated relationships like this, where you have some potential many-to-many relationships, and you're trying to group some things together. I think it works well. A couple of things that I'd just like to point out. In the fact table, I like to consider, putting some of my business keys in there as well. So maybe what I would do is I might put my customer account number and attach that to every record. And the reason being, sometimes when I'm doing my ETL and doing lookups, and I have lookups fail sometimes, so then I end up with an unknown key because it couldn't find that customer account number for some reason. And when it's the day after the ETL's run and all you have in your fact table is a key that says -1, sometimes it can be rather tricky to track that down. But if I include that customer account number in my fact table that I use to do the lookup, that can kind of be a nice starting point for some troubleshooting. So, of course, I take into account, like how big the fact table is and how many attribute keys I need to store. But I like to think about doing that sometimes too, just because it does help with troubleshooting and reporting down the road.
Yep.
So that's one thing that you might want to consider at some point.
Cool. Yeah, no, that's a really good point. And the other thing, too, is oftentimes you build the dimensional model in an incremental or an iterative fashion. And so sometimes all you may have at this point is the natural key for a column, and you need to link it back to some stuff that's still in your staging area. Maybe you just replicated tables over from a new source system, and that's the only connection you can make, and you haven't had time to do all the ETL work necessary to source that data up. So we can go to the next slide and look at some of the other patterns that the customer requested. And the first one is we'll look at as analysis bands.
Sorry,
So,
Jason. Before we continue on, we do actually have a question related to this previous slide with the
Sure.
with this diagram. So one of the questions is order band intended to be discretization?
Is which one?
The order band.
Oh, yeah, exactly. It's binning or discretization. So the idea is that the order quantity could have a continuous set of values, 1 through whatever, in integer steps, and we want to do some binning or some grouping of those. And I think Reeves had mentioned that earlier. So we're looking at how to solve that with this analysis bands. And there's 2 approaches. And I'll start with the approach that I don't see a whole lot, but I think there is some value in this, which is basically creating a table defining what's your minimum grain going to be. In this case, if we look at the table on the left, the minimum grain is 50. And we're going to say, okay, we're going to add a record for 50, 100, 150, 200, so on and so forth, and assign that small, medium, or large. And then what we can do is in the fact table, or I'm sorry, in the ETL process, we can actually assign that key based on a simple mathematical calculation, and then we get a very simple single column join. Okay? And what that allows us again to do is to kind of bucketize this data and use it for reporting purposes. Now, the other thing you might want to say is, well, what if I need to handle things that change over time, and I want to see what was the current version versus the historical version? You can add a begin and end effective date stamp on those and handle it as a type 2. You can also store multiple groups in the table. In this case, if we look at our alternate approach, I've added a banding group field for order quantity. But in this case, I've had a band, I got those backwards, I guess, a band begin and a band end, and the names are flipped in the diagram there, and a value. So what we would do is do a slightly more complex join, which can work in certain environments with certain data volumes, where you say you can either use the between operator if you know what you're doing, or you can use less than or equal to and greater than or equal to, and join those back and get the right band for a given row. And that's just a way to add those bucketizing. Now, Analysis Services also supports some of the discretization built in, but I've never seen anybody use that successfully in practice. It doesn't really work. It works, but it doesn't do what you want it to do. It doesn't give you the kind of control you need over the bands. So that's the banding pattern. We can move on to the next one that I think is kind of interesting, which is the conversion factor pattern. And this is a pattern where we've got multiple units of measure that that we might need to report on. So in this case, we're looking at units, retail packages, shipping cases, and pallets. And we may even get the data, depending on what source system we're coming from, in different units. So what we'll do is we'll kind of normalize those units to what we're calling our base unit, which in this case is individual units. And we'll store a conversion factor for that row, as well as we may also have a conversion factor table that has some other metadata that we'd use for report labeling. Then what we would do is we'd store the fact in terms of that unit, and then if we needed to, for reporting purposes, report on shipping cases, we could just do the multiplication by 0.1, and that would get us back to our individual unit number. So this works really good for things that are relatively static, like our units of time, units of measurement, for example, like area. I use this a lot in my work at the satellite imaging company that I work at, where we're reporting on area, and some people want to see that in square kilometers. Other people want to see that data in square nautical miles. And currency works really well. Now, there's a bit of a wrinkle with currency, because a lot of times you really need a fact relationship with currency, because the currency rate is effective as of a given point in time. And so you have to add that into your model for that to really work. But some cases are much more simplistic, and you can just get away with the conversion factor. We can move to the next slide and look at the warehouse. So, you know, the dimensional model is starting to pick up steam. People are starting to use that. They're really pleased, and the warehouse manager says, you know what, I could use this in the case of our order fulfillment tracking. And this gets back to the question we had about the status tracking table. And if we move to the next slide, I'll show you guys what I mean by that. So in this case, we're doing an accumulating snapshot fact table. We've added role-playing dimensions for all the different points in time. So if you look at this timeline chart at the very bottom, we've got a quote, we've got order, we've got released, we've got picked, we've got QA, we've got shipped, we've got delivery. And these are all time points from a beginning time. And so what we're going to do is we're going to store the lag between, for example, quote and ordered in our fact table. And then what that gives us the ability to do is as the business process comes or starts, so for example, we get a quote, we add a record to the fact table. And when it moves from quote status to ordered status, in other words, what we do is we come back and update that fact table. Now, generally, you don't want to update fact tables, but in this case, it's okay because we're tracking a business process. This can also work for manufacturing processes, all sorts of other types of processes. And so not only did we create all these different role-playing dimensions for the dates so that we can do transition matrices and say, well, how many orders went from quote to delivery in this time frame, how many went from quote to cancel in this time frame, so on and so forth. But we can actually anticipate any other combinations of these units. So for example, we can say, well, what was the time from quote to QA? Or what was the time from release to pick? Or release to ship? Or release to delivery? So we can combine those just by adding the numbers. Now, the key thing you have to do is you have to put constraints on these lag values so that you don't go backwards, right? It always needs to be a non-negative number, and your data quality has to be really clean in order to support this pattern. And sometimes you may just store the timestamps in addition to the lags, just to be sure. So that's kind of another way that I would look at that status history table, is this stores it all in one row as opposed to, let's say you have a process like document publishing where you have maybe 5 discrete statuses. In that case, you'd have 5 rows per the transaction, right? In this case, you'd have 1 row per the transaction with 5 different status milestone checkpoints, if that all makes sense. And if we go to the next slide, just an example of selecting the proper data type for the range of what you're trying to store. I generally recommend tracking things at the seconds level, and an integer data type covers that pretty well, and 9 times out of 10. So that usually works. I wouldn't recommend some of these smaller data types, but in certain scenarios where you really need to squeeze the most performance from the data model, it definitely is something that you can consider doing. So I hope that answers the question in full that we had at the beginning of the session. But that would be the 2 ways that I would approach that. I would have this fulfillment fact table, and then possibly a status history table as well. To moving to the next slide, you know, the HR department wants to get on the act. And again, that pattern that we just looked at, that was the accumulating snapshot pattern. And the first one we looked at from the very first data model was a transactional fact table. And now if we move to the next slide, we'll see how they're going to do their HR analysis. This is a case where we're going to have a semi-additive table, and it's going to be a periodic snapshot. And the point here is that at each day, we're going to take a new snapshot of the current values for overtime paid, salary paid, employee count, new hire count, transfer count, so on and so forth. And so it'll be additive across all the dimensions except for the data capture dimension. So another business area where I've seen this pattern being used to a pretty good result is the airline industry, where each day you capture what are your current booking levels on a given flight, and you can build a curve then that shows how fast are you selling tickets. And the point of that is that as ticket sales increase, you want to charge more money because there's less seats available, so that you can get the maximal revenue out of a given flight. And so the analysts will track that curve and make sure that it's approaching the right level. And if they find flights that aren't selling so well, maybe they reopen lower fare buckets for sales or what have you to try to get the airplane to leave full. So that's the periodic snapshot. Now, the other thing you'll notice here is that we've got a organization dimension hierarchy, and that's your standard parent-child hierarchy, where you just have a recursive relationship from the organization to the parent. Now, that works pretty well in analysis services, multidimensional because it supports parent-child, but with really large dimensions, that can get kind of cumbersome, so you have to look at some other techniques sometimes if you can. We can move to the next slide.
We actually, before we continue on, we actually have about 5 minutes left.
Okay.
Yeah, thanks.
All right. Yep, no. So basically, for hierarchies, you've got a couple things you can do. If it's a fixed depth, you can do a type and subtype, 2 different attributes, or we can do how we did with the calendar. So you do the year, month, day. You can do country, city, state. Ragged, sometimes for products, organizational or sales hierarchy. And then you can have deep raggeds, where you have a lot of different levels, and there, some may only go 2 to 3 levels, some may go 7 or more levels. And so if we go to the next slide, just an example of a simple hierarchy. And sometimes you can take a ragged and turn it into a fixed depth by either using coalesce and null and storing the last value. If we go to the next slide, we talked about these ragged hierarchies, and these typically get to be really complex. And if you can't use a parent-child, you can use an advanced pattern like a closure table, which basically stores one record for each attribute back to the parent and back to all the children. Or you could use a nested sets, which is a little bit more complex. And we don't have time to get into all those, but just know that there's design trade-offs typically around the ETL versus the query performance when you choose each of these different types. And if we move to the next slide, just summarizes, we've talked about role-playing dimensions, degenerate dimensions, which is where we take a transactional identifier, stick it in a fact table. Junk dimension we didn't talk a whole lot about, but that's where we have a lot of low cardinality attributes, and we stick them in a single table, typically for to simplify the dimensional model and not have a bunch of single attribute dimensions. Moving on to the next slide, we have a summary of our different fact table types: transactional, accumulating, and periodic snapshot. And one thing that we didn't talk about, factless fact tables, where we're storing counts, sometimes like enrollment counts if you're thinking about an educational vertical, where there isn't really a measure, it's the intersection of all the dimensions is the measure. And sometimes you can stick just a value of 1 in there for a measure to get away from that, and sometimes you don't. It just kind of depends. So I guess with that, we can move to the next slide. Some common problems. Just talk through these really quickly. Too many dimensions. So you have the centipede. Usually you want to have I shoot for 7 to 12, depending on the complexity of the model. The thing I look for is if I have a lot of dimensions with only 1 or 2 attributes, I think, can I consolidate this into another dimension table and still have it make sense to the business person? Again, grain compliance. So you define a grain for a fact table or dimension table, and then you stick to it. You don't put aggregation measures in there. You don't put data that doesn't make sense at that level. Patterns for storing text data in the fact table. Sometimes you can turn that into a dimension. Sometimes you can't. Micromanaging dimension field size. I prefer integers, primarily because it makes things simpler when I'm working with analysis services. But with a really large dimensional model, sometimes a tiny int, if that covers all your dimension keys, is the right choice. We talked a bunch of times about using operational keys to join tables. Sometimes it's the only option you have. So definitely put those in your models, like Josh had suggested. I think that's a good thing to do, especially if the tables aren't super huge to begin with. But use your surrogate keys if they're available to you, because an integer join is going to perform better than those operational keys. And then, when you look at your requirements analysis, don't just look at the current report or a suite of reports. Think of the data that you're going after in the source system and get as much of it as you can, knowing that there's going to be a trade-off between scope and time, right? So time is fixed, you got to go after less attributes, but you don't want to have to re-extract that data out, because sometimes it may not be in the operational system anymore. So with that, I think we can close it up, and if we've got a couple minutes, maybe just one or two, to take some other questions, or any of the panelists can add some thoughts.
Okay, sure. We do have a question here, and I think it would be a good idea for the other panelists to add or to answer the questions as well. So the question is from Felix. How do you handle data from third party with inconsistent master data? Let's say the transactional data has a key which just is not in the customer master data. Anyone? Carlos, maybe?
I can take that one if you want.
Okay, go ahead, Josh. That's okay.
If you want Carlos to take it too, that's fine.
No. Josh, go ahead.
So, I mean, that's a great question, and how we kind of handle that. We have to have some way of handling that, and it can be handled in the ETL. So we can have some processes that translate those inconsistent keys, and we may look at using some of those special table types, like Carlos and Jason had mentioned. And some of those table types, like we might use some reference tables that don't actually supply keys for the data warehouse at all, but just store some of that reference data. Another way we can handle that is actually by implementing some master data management processes. And there are a couple tools in the Microsoft stack that help with that, those being master data services and data quality services that kind of can work together to help manage some of that master data that brings in those third-party sources and ties it back to your data warehouse that has your corporate approved sources. So, I think it's tricky. It's not an easy question to say this is exactly how we do it. It's definitely an implementation by implementation thing, but there's a lot of support there that we can lean on.
Yep. One thing I would add to that too that I've done is oftentimes, and this is kind of in line with what Josh was saying about master data services and data quality services, is I have an error fact table that I run the data in my ETL through this error fact table. And what I do is I say I have my business rules, and if the data doesn't meet a certain level of quality, I reject the record and don't move it into the dimensional model. And then I would use a tool like Master Data Services or GQS to clean that data up, or go back to the source systems and get that data fixed in the source systems. Because in general, if you have that problem, the best thing you can do is fix the data at the source. But a lot of times in the real world, you can't do that. So I often have tables that store kind of what I call my unreported data, or data that doesn't meet the basic quality gates to push it into the dimensional model. And then that's why one of the reasons we use surrogate keys is so that we can mark those records with the unknown attribute, or maybe we can have another record that says, the data, just to signify the data didn't meet the quality standards for this record. I don't know, Reeves or Carlos, do you guys have any thoughts on that?
The only thing I would add to that is often I see people trying to do some complex process to load that into the star schema directly, and I would recommend everybody always stage that data first, clean it, and do some of the things Josh and Jason are suggesting before it actually then hits the data mart. So when you hit the data mart or the star schema, you're going to be, you have some confidence that it's going to be clean. I think sometimes people avoid moving the data several times, and I think in cases like that, actually try to move it somewhere first before you move it somewhere else, and it'll make your life a lot easier.
And then one other thing to add to that is there are some cases that you just can't write enough complex SQL to figure it out, and that's where a tool like a Master Data Services lets users come in and fix some of those that would just take you too long to try to write a case to get that. And that's where these tools come into where you're just data stewards that can figure that stuff out way faster than trying to write some kind of magic SQL to be able to get that figured out. So a lot of it is just manipulation by a data steward on some of those cases.
Yep, for sure. Any other questions, Julie?
No, that's it. But we do have a comment here that this discussion is related to late arriving related dimension.
Yes, for
So,
sure.
yeah.
It definitely is. And so that's one of the things is oftentimes the reason you won't see those keys in the system is because the data is out of sync. So sometimes you may have a multi-tiered isn't really the right reason, but you may have multiple source systems and you may have different frequencies to those source systems, and sometimes the data that you're capturing is spans those source systems. So for example, maybe I only pull data out of my customer relationship management system every night. Maybe it's in Salesforce, and I have to pull it over a web service, so maybe it's really slow. But I've got my order system, which is in-house. It's internally developed software, and maybe I have a service bus or something where I'm getting XML messages, and I'm getting that data near real time. So some of those issues kind of come up in an ODS, and oftentimes what you'll see is the data kind of come in as the systems can provide it. And so what you can do is you can initially mark the transaction as it's late arriving, so the data is currently unknown. But if you check back tomorrow, we've then got the data from the source system and we've updated it to the right value. So that was a really good comment by that person, because it's definitely the case that I've seen in practice where this happens, other than the case that the data just doesn't exist for some reason. It was removed, or there was some bad data quality issues, which is why it's really important to force back on your source systems that they actually use foreign keys and they use referential integrity and constraints and these things, because it makes your job as an ETL developer and a dimensional modeler much simpler when you can kind of expect that you're getting clean data. Of course, your ETL needs to be bulletproof, right? It needs to realize that it may get data that it can't deal with, and like Reeve says, in that case, you have to have a data steward, somebody that knows the data enough to figure it out, right?
Okay, so we do have another question. I'm happy to leave it open. I'm not quite sure if the panelists actually have to go somewhere because it is already past the hour. It's up to you, Jason, if you want to address another question.
Let's keep going. I mean, and if any of the other panelists need to drop off, I'm happy to stay here as long as we have questions coming in. So.
Okay, no worries. Thank you for that. So there's a question here. How do you decide to add a new dimension instead of adding fields to existing dimension?
Carlos, you want to take that one?
Yeah, I think I'll do that. A lot of it depends on the hierarchy of the dimension, and is there a natural hierarchy in that same dimension? So if there isn't a natural hierarchy, I'm kind of turning it into a junk dimension where I'm putting disparate columns all together, but without there being some kind of a natural way to go up or down those columns. So if that's the case, I will always try to put it in a different dimension and try to establish its own hierarchy. So for example, we saw the example earlier of geography and customer, and you could have geography be in the same dimension above the customer, and there is somewhat of a natural hierarchy there. But also in a case like that, I may have data that relates only to geography and not to a customer. And so that would also make me split it out into its own dimension. So I think part of it depends, do I have a natural hierarchy? The other side of it depends on, do I have fact data pointing to the whole hierarchy or just a portion of it? And if it's just a portion of the hierarchy, then it means it's two different dimensions.
Yep, that's a really good point. And sometimes what you have to do, you always want to strive to use the conformed dimensions. But sometimes you have a situation where you're looking, maybe you're forecasting at a quarterly level, but your actual detailed data is at a daily level, and it can be difficult to decide how do you handle that granularity. Do you try to somehow use your existing date dimension and maybe put like a materialized view on top of it, or do you just create a dimension that's at the quarterly grain? So it's those kind of things that you just have to kind of think through, and hopefully, the business users are smart enough to help guide, give you the right clues to make the right decision. But you want to be flexible in case you don't get it right, so that you can go back and fix it too.
Yeah, we do have a comment here that from an audience that I think sometimes it might be granularity, or it might depend on the granularity of the fact table as well.
Yep, and Carlos kind of spoke to that a little bit, but also dimension granularity. if adding that attribute to an existing dimension is going to change the granularity, you have to think hard about whether you want to take that on, because it'll ripple, especially if you're using conformed dimensions in a Kimball methodology, it'll ripple to all your other consumers of that dimension. So it might be better and maybe less intrusive to create a new dimension, you know. But again, you don't want to have 50, 60, 70 dimensions. But it just depends. Each case is going to be different.
Yep, that's right. Okay, so I think that's the last comment from the audience. So anything else that the panelists wants to add now?
My only comment I think to leave the session with is I think people should really pay attention to factless fact tables and accumulating snapshot facts. I see a lot of people sometimes has struggled with creating a fact table that they can't put a value in that fact table or something they can measure, and it's perfectly acceptable to measure the existence of a fact, right? Just the count of the row is good enough to be a measure that can be used, and some people really struggle with that. And then accumulating snapshot facts, I see people struggle with that a lot, where they need to, we've already built a lot of the sales fact data marts or a lot of the sales fact star schemas, and now a lot of the stuff we're doing has to do with business processes. And you just can't get away with doing a business process without having accumulating snapshot fact tables. And you need to track events, you need to track things that are happening. So I would tell people to really pay attention to those two types of fact tables.
Hey, Julie, can you go to slide 38 real quick?
Sure. Let's see. Sorry. Where is it? Sorry. Let me just go back to the PowerPoint. All right. So this is slide 38 showing now.
Okay. So this is the references slide. And I think this is one of, I'd say, the biggest takeaway from this discussion is there's these books out there, right? So there's Data Warehouse Toolkit, which is a Kimball book, 3rd edition. Star Schema, the Complete Reference, which is a little bit of an older book by Adamson, but I know Carlos and I are both really big fans of the Addison book. Agile Data Warehouse Design, I got this from Scott Shaw out of St. Louis, and it's a really good book. It's up on Amazon. It's very thin. And the thing I like about it is it actually has some coverage of a methodology called BEAM. It's not really a common methodology, but it's an interesting methodology, and it has some outlines of how do you go from requirements analysis to construction of your dimensional modeling. In addition, it covers all of the basic stuff that you need in the Kimball dimensional model. And then Mastering Data Warehouse Design is a book by Claudia Imhoff and a couple other authors, and she really dives into some of the hierarchy design issues as well as the aggregates and some of the other stuff. So I'd recommend getting one or more of these books, because oftentimes the author will present it in a different way, in a different text, and so sometimes you can it might not make sense to you in the Kimball book, but maybe in the Adamson book it makes more sense. So I think it's important to go out and use these resources and prosper.
Okay.
Yep.
Okay, thank you for that. I think there are a couple of questions still, and I'm thinking of just ending it now. And for more questions, I'll just refer them to you to answer. Now, do you have a contact detail on any of the slides so that the audience can contact you directly?
Yeah, for sure. So if you go to slide 2, it's currently hidden.
Okay.
But that's my kind of introduction slide.
Right.
And what I prefer for people to do is first of all connect to me on LinkedIn, and then just reference that they were in this past BI virtual chapter meeting so that I have some context around it. Or they can email me directly, jason@jasonhorner.com, or they can use Twitter. And I know a lot of the other speakers are out there as well on those mediums, and so I'd encourage you to reach out to those guys as well too.
Yep, excellent. So as you may already know, we do have Twitter account at PassBIVC as well. So if you want to raise any questions there, we volunteers usually monitor the Twitter account quite actively anyway. So yeah, so thank you very much, guys, for a great presentation. I think it works really well with the interactive discussion, and I understand that there was a bit of technical issues. So thank you very much for the audience for their patience and understanding. These things happen to us at sometimes inconvenient times. So. Okay, so I'm just going to stop the recording soon. So before I say goodbye to everyone, thank you, Pragmatic Works, for sponsoring today's session, and there will be a free ebook giveaway for one lucky attendee, so I will be emailing out the lucky attendee. Any last words, panelists?
I'm good.
Okay.
Thank you for having me. Appreciate it.
Yeah, thanks, guys. Thanks, everybody, for helping me out. Sorry
Thank you
about
very
the
much.
technical issues.
Thanks for doing it, Jason.
Okay, thank you.